Thank you very much, Atish, and I want to thank Atish Dabelkar and Fernando Quevedo for organizing this in memoriam session and for inviting me to speak, which is a humbling experience and also difficult because, on February 2nd, we lost Joe, who I've known him since the mid-'80s, and he definitely had very profound influence on my whole scientific trajectory, and I think that of many, many other people. I should add a disclaimer that although I was certainly friendly with Joe, I feel like I should have known him better personally, and the main obstacle is that I am not athletic. I think to get to know him well, one needed to do this extreme biking that he did, and all kinds of. He was extremely athletic and passionate about sports, and that's where I was definitely lacking. So just a few words about Joe's life story. So he was born in 1954 in White Plains, New York. Apparently his family moved around quite a bit when he was young. And so he graduated from high school in Tucson, Arizona. And then, as he himself often says, a really important experience for him was to be a student at Caltech, where he got the Bachelor of Science degree in 1975. And I should say he wrote the memoirs during his remission back in 2017, so you can read in his own words much more about his life than I can say in this brief talk. And then he went on to be a student of Stanley Mandelstam's at Berkeley, and got his PhD degree in 1980. And apparently, while a graduate student, he didn't write very many papers at all, but he still impressed people very much by his depth. And then he was hired as a postdoc first at SLAC, Stanford Linear Accelerator Center, where I think his main postdoctoral mentor was Lenny Susskind. And then several years later, I was a postdoc at SLAC and also worked very closely with Lenny Susskind. And that was the place. I remember his visit to SLAC was one of the first times I actually got to talk to him. It was somewhere around 86 or 87, and remember chatting with him and Lenny. So Joe, I think while at SLAC, his productivity started going up. He wrote some very interesting papers there, and then he moved on to Harvard, was there as a postdoc from 82 to 84, and then right around that time, Steven Weinberg moved from Harvard to the University of Texas at Austin, and he invited, I think, Joe Polchinski to move there as a faculty member, as a professor. So Joe indeed moved there and was there from 84 to 92, which were really productive years for him. And actually, one of the remarks I recently saw from Weinberg about Joe is that he wrote in some web forum that attracting Joe to University of Texas was probably his biggest triumph, and letting him go was the biggest failure for the Weinberg theory group at Texas. But then what happened was that a position opened up at KITP, which is a very select institute. It's a mostly research job, and this position was offered to Joe, and he moved there in 92. I actually remember coming there in early in 93. There was one of these programs there, At that time, it wasn't called KITP yet. It was called ITP. Kavli was added a bit later. And this was even before the new building was there. They were on the 6th floor of Ellison Hall. And I remember just sort of walking into Joe's office and saying, "Oh, you've moved." And he said, yeah, I'm now here. I'm happy to be here. And this was, so Joe really fit amazingly well at ITP. And just a couple of years after his arrival at ITP, there was this tremendous breakthrough with Dbranes, which I'll talk about soon. And he was there until 2017, and unfortunately, late in 15, we learned that he got very ill. He got a brain cancer, and he was operated early in 16, and was actually in remission for a while. Was doing a lot better for a while, but unfortunately got worse again late in 17, and we lost him on February 2nd. So I think it's impossible. So I was asked to just say a few words about his scientific profile and work. I should say that I've always sort of looked up to him and regarded him as a more senior colleague and a kind of someone I often followed. I think his papers probably resonated more with me than just about anyone else in the field. And his style was really amazing. I really admired his style of doing theory. So I just, I would say every single one of his papers was good, great. The quality, I would say he always emphasized quality. The quality was simply superb. He just wouldn't write until he was very confident of the results. I think many of you probably know of him through this monumental effort, which is the 2-volume textbook on string theory. I think when you see these two books, it doesn't convey the full story of how much work he put into that. I think these books would expand to like twice the size you see now, and then he would basically prune them and go back and forth. They would sort of oscillate in size. So it was truly an incredible service he did to the whole field, not just string theory, but the whole field of theoretical physics. So this is something what many of the students know him from. In terms of the story of his research, so I mentioned already that he worked closely with Susskind in the early 80s and made a lot of progress on supersymmetry breaking. Then when he moved to Harvard, he started working on these more foundational issues, kind of things like the nature of renormalization group. So there is this famous Polchinski equation for a normalization group, which is one of the defining steps in this whole Wilsonian program. It's a very beautiful paper, very well-known. It's not a string theory paper. It's just a general field theory, theoretical physics paper that I think everyone should read. And at that time, I was just a starting graduate student, so I don't remember when this paper came out. I knew very little then. But this paper I remember well, one-loop string path integral. I actually first heard about it when I was a summer school student. There are these TESI summer schools, Theoretical Advanced Study Institute. They were set up in 84. 84 was the first one, and I was a student at the second one. And the second one was a pretty dramatic period, like right after the so-called string revolution. And many speakers were added at the last moment. There were many guest speakers who talked about string theory. And one of the guest speakers was actually Steven Weinberg. And I distinctly remember he's of course a giant in the field. And when he showed up, the first thing he said is, "I will not talk about my own work. I will talk about the work of Joe Polchinski." And everyone certainly noticed that. And he talked about this calculation of one-loop string path integral, which is a beautiful calculation, and some other stuff that also he was discussing with Polchinski. Then there is this something that's resonating now a lot is the relation between scale and conformal invariance. When does one imply the other? It's a very active field of research now. Then in 1989, actually that year, I wrote only one paper with Joe. It's a paper called Quantum Mechanics of Googleplexes with Joe and Willy Fischler and Lenny Susskind. It's one of these baby universes paper. Was inspired by Coleman's theory of cosmological constant, which was very hot at the time. So that stuff was a little bit squishy, kind of. So we spent quite a while going back and forth on that paper, but right at the same time with his students, Dai and Lee, he basically wrote a paper introducing Dirichlet branes, where you put in basically mixed Neumann-Dirichlet boundary conditions and open strings. And as Atish said, it wasn't immediately noticed. It was viewed as a kind of cute thing, but it wasn't immediately noticed. And then a few years later, that was really an amazing breakthrough, the realization that Dbranes and superstring theories carry these Ramon-Ramon charges and actually are BPS-saturated objects, namely the charge repulsion is exactly canceling the gravitational attraction, and they immediately earned their place in this whole field of string dualities. I will talk a bit more about the appearance of that paper soon. For example, quantization of fluxes and string landscape, the famous work with Busso, where they pointed out that one can get a landscape of compactifications by putting in fluxes and quantizing them. Then in the same domain, hierarchies from fluxes, that involved things like embedding the warped conifolds into compactification. So it's closely related to my work with Strassler around the same time on confining gauge theories and warped conifolds. Then he actually, right at that time, he had very fruitful several papers with Strassler. One of them was hard scattering and gauge string duality. Then there was also work on gauge theory from dual backgrounds and Pomeron, forward scattering and things like that. And then he also made a very big impact on the appearance of techniques of integrability in ADS-CFT. This was one of the first papers which pointed out that there is these extended symmetries starting from the string side. Around the same time, there were papers on extended symmetries from the field theory side. Then there were, of course, there was a whole series of other great stuff. There was work on cosmic strings. But one paper that's really resonating now and continues to resonate is holography from CFT with Hemskirk, Penedonish, and Sully, where they stressed this whole idea of a large gap in the dimensions of the spectrum as the important thing for weakly curved gravity duals. Just a couple of years after that, the very famous work about complementarity or firewalls, where this whole basically they showed the conflict between complementarity and some quantum information issues, and were led to the possibility that there can be a firewall at the black hole horizon for some black holes. This was the work with his student Alm Hayri and Don Marolf and another student, Sully. So this is just a somewhat random selection of the papers. And you can read much more in his memoirs, which he wrote in 2017. So altogether, he wrote close to 200 papers of really high quality. Of course, very highly cited, all that. But I think it doesn't convey the full impression of his role in the field, because many times, even in papers that are not that well known, he would he was sort of the go-to person to sort out the difficult kind of conflicts of opinion between different groups. Like sometimes he was one of these very, very few people that would be trusted to go in, learn the field, and pass a kind of definitive opinion. So actually one instance of this was going back to this Coleman's theory of the cosmological constant. I worked on it with Lenny Susskind when I was a postdoc, and there were some doubts, but then it was Joe who essentially killed the theory. And he killed it by just realizing that if you look carefully at, it was like sum over spheres connected by wormholes, he realized that the distribution for the cosmological constant was not exponential of the exponential of 1 over lambda, but it was really exponential of minus exponential of 1 over lambda. So he realized that there was this subtle minus sign and wrote a paper called The Phase in the Sum Over Spheres. And that paper absolutely set the record straight. And so it's maybe not a very well-known paper, but it played a huge role in the late 80s. So it was, and that sort of story repeated a number of times. And now I, of course, you know, so he left a huge void in our field. And of course, it's a huge loss for his family. So, yeah, sorry. So let me just read a message from, he left his wife, Dorothy Chan, who is a professor at UCSB, and 2 sons, Daniel and Stephen. And Dorothy sent this message that I want to read. Just, I think she's grateful for this in Memoriam session, and she wrote, Joe's family would like to thank everyone for the tremendous outpouring of sympathy and kind words about Joe. Of course, we're sad beyond words that he left us all too soon, but it seems that as though he touched so many people's lives in such a positive, meaningful way, both in the physics world and beyond. We feel that he's with us in our hearts, and we will be inspired to live our lives in the way he lived his, with passion, kindness, and humility. So, yeah, definitely, it's very sad he's not with us. And I notice that people still talk about him very much in the present, because, in fact, his recent work on this with Almheiri on ADS2 gravity and his work on the Sachdev-Kitaev model is so much resonating now. So no one talks about him in the past. I think people, you can feel his impact right now as we're working. And of course, you know, his work was recognized multiple times and by important prizes, but I think it still doesn't fully convey all that he meant for the field. So I just wanted to, it's a little hard to believe, this whole story, because just 4 years ago, there was a 60th birthday conference that was dedicated to Joe, and it was aptly called From the Renormalization Group to Quantum Gravity, celebrating the science of Joe Polchinski. And it was a very happy event, very upbeat event. He himself was extremely happy during those 2 days, very memorable. And I was honored to be one of the invited speakers, and I can't resist showing literally one of the actually the first slide of my talk. And here is the slide. So it basically, about the day the Dbrane paper appeared, and literally it was a jolt. It was an incredible jolt. And the circumstances for me were that it was early in October, and Witten actually was giving a series of lectures about string duality in Princeton, which which were extremely well attended. Like the size of the group was very impressive. People were coming from Rutgers, New York, I'm in Philadelphia. There was a very big group of people. And I think he got through the first two lectures. And then I believe something like on Thursday night, there was this short posting on HepTH, and many people probably didn't even immediately notice what was called Dirichlet branes and Ramon charges. Sounds like pretty obscure, but I remember the next day, which was, I think was Friday, Witten started his talk by saying, oh, I was planning to talk about X, Y, and Z, but Polchinski just threw in a monkey wrench in my entire plan. So the whole plan of the lectures has to be revamped. And then after the lecture at tea, I remember someone saying, finally, we have the brains that we can think with. Because before then, people talked a lot about these supergravity brains, and they were these somewhat mysterious classical solutions. People didn't quite know what to make of them. And suddenly there was this amazing technique that you could really, so immediately the field took off in many directions. One was brain constructions of gauge theories, and of course pretty soon the ADS-CFT correspondence was formulated based on Dbranes. And I just want to quote, this is verbatim from Joe's paper, just to show that he basically, the germ of the idea of the correspondence between multiple Dbranes and these charged gravity solutions was there. Basically, it said this result for the Dbrane charge is new evidence both for string duality and for the conjecture that Dbranes are the RR charged objects required by string duality. Presumably, one should think of them as an alternate representation of the black P branes. Namely, that this is basically the gauge gravity duality, like and of course this was, so I was one of the people immediately to jump on this field of Dbranes, and I will forever be grateful for that paper. It truly, but I think it meant a lot to many, many people, the entire field. And I just want to end these remarks by saying that so this is sort of all well known, and you can read in the memoirs, but one thing that sticks out in my memory is something that happened just a few months before that. So this was October 95, but in late March, early April 95, there was a spring school here, like in this very room. Yeah, just imagine what it looked like 23 years ago. To me, it seems like it looked, yeah, right, maybe much nicer. Yeah, but I remember this place well because, as I mentioned, actually, I first lectured as an invited speaker in '91, but then in '92, I was invited to be a co-director of the school, together with Robert Dijkgraaf, who now has the high position of being the director of the Institute for Advanced Study. So we were together, the external ones, and the internal directors were, I think, Yango and Seif Ranjbarda and me. I may be forgetting someone. Narayan, yeah. I'm sorry. Yeah, so this was a great times. I remember in '93 we had Toft, and so it was but the '95 school was especially memorable. We had, so the speakers included Joe and Lenny Susskind and Nati Seiberg, who talked about his newly discovered dualities, and Ashok Sen, who talked about big progress in black holes. And one of the students at the school was Juan Maldacena. In fact, I chatted with him the day I was leaving Princeton, and he remembers the school very well. And he actually said he learned a lot about black holes at that school. Like it was, so I very vividly remember these these interactions and, the dinners in Mignon, Pizzeria, and stuff like that. And so it was right before the big revolution, but on one hand, you couldn't quite tell that the revolution was about to break out, but one actually funny thing that happened was that there is this folk legend that Joe Polchinski once fell asleep during his own seminar. Okay, that was during a lecture here, and he was like literally standing here. I think the story, what really happened, because I sat in the audience, what really happened was that he was very jet lagged, from California, it's a little hard. And so he was like sort of complaining about it periodically. And he was lecturing on, I think the subject of his lectures was what is string theory, although he also talked about black hole complementarity and things like that. So towards the end of the lecture, he started kind of spacing out a bit. And then there was a bit of a break where he closed his eyes. I don't think he really fell asleep, but then he said, oh, I better continue next time. So I think I wouldn't call it falling asleep, but so that was one of the funny stories from the school. And another thing I remember him saying was that I've spent quite a while thinking about these foundational issues like what is string theory, but I kind of want to be really in some hectic new field now where no more philosophy, like things are happening fast. And amazingly enough, his wish came true just a few months after that, because after the Dbrane story came out, things were moving at lightning speed. And one thing I remember, so in those days, as organizers of the school, we had to hound the speakers, like, please send us the write-up of your lectures. If you look at the book of the proceedings, Joe's lectures are not there. And I do remember him sending me email, I hope you will forgive me, but I just really can't think of writing up more lectures about what is string theory when, like, there are 10 papers and Dbranes coming out every day. And of course, we were understanding for that. So I think I've already taken up too much time, but just want to end with expressing enormous gratitude to him for all that he's done for the field. I mean, I think he really is a giant in our field.
Okay, thanks, Igor, for a very nice view of Joe's work and life. So now I invite Ken, interrogator, to say a few words.
It's on? Okay. Yeah, I kind of, from the time I was a student, grew up admiring Joe Polchinski. He's 12 years ahead of me scientifically. And the first time that I heard a talk from him was at Strings conference at Texas A&M. And when I was in graduate school, I was a graduate student at Harvard of Kumran-Vafa. And at the time, Sidney Coleman was very excited about having solved the cosmological constant problem. And so we heard many talks about this. And Sidney Coleman was also having these very, very bitter debates with Stephen Hawking over this whole thing. And so at this Strings conference at Texas A&M, I remember, this kind of amazing young person, Joe Polchinski, gave, incredible talk. And basically he was talking about the thing that Igor mentioned, which kind of killed off the whole thing. And it was kind of always just so impressive to see not just how deep of a thinker he was. I mean, he kind of had this different way of doing physics. I think it was more maybe like when I hear stories about how Feynman did physics and also how Lenny Susskind does physics, it's kind of very conceptual, kind of deep thinking where they could look at any kind of problem maybe that's been studied by many, many people and just kind of look at it from a different angle and make some very interesting and insightful kind of observations about it. And so I always incredibly looked up to Joe for being so deep in the way he would think, the way he thinks. But also I looked up to him incredibly just because he always seemed like he was having so much fun. Like in these pictures where he's smiling, he always, seemed to be very happy and playful. He had this nice kind of way of doing physics where just whenever he was around, I felt happy, happy to see him, and there was like this energy that he had with him that was just incredible. And I studied many of his papers. One of the ones that Igor mentioned was this one with Susskind on supersymmetry breaking, which isn't really a very well-known paper. It was one of his very early papers, but it was just such a brilliant paper to read it, and there were many things in there that I think people kind of didn't really pay enough attention to that paper. There's some fun stuff, and also like when I wanted to learn about some condensed matter type things, I read his paper on effective field theory of the Fermi surface, which is also highly would recommend it to students who want to learn about this kind of thing. It's a beautiful paper. Unfortunately, I never got the opportunity to collaborate with him scientifically, but we did collaborate together on a workshop. It actually was thanks to Igor, who was on the KITP board, they asked me to organize a workshop in 2014 on kind of modern methods in quantum field theory. And I was a little nervous to take on the big responsibility of being director of this workshop. And these KITP workshops, the planning for them is incredible. I mean, they start planning for it a couple of years in advance. And fortunately, Joe kind of agreed to come on as a kind of co-director. And it was just incredible once he came on. I mean, he really was so responsible. We communicated constantly over emails about the program. And then once I got there in 2014, we spent a whole 4 months kind of collaborating on this program. And it was just great getting to know him. And this time also coincided with his 60th birthday conference. And so I was there for that. And yeah, he really was very happy and so happy and alive at that time. And I also got to know him through going on bicycle rides at that time. He was a really avid bicycle rider. So every Wednesday afternoon, he would organize a bicycle ride up from the KITP up this hill. And it was maybe about an hour ride round trip to do it. And it's kind of a nice gradual climb for a while, and then it suddenly becomes extremely steep. And so, we're kind of just riding along, chatting and everything. But then once it gets to the steep part, he just takes off like a rocket. But then he'll nicely wait up at the top for people and kind of give a lot of encouragement. And also on the way down, he just went down way too fast. It was actually scary watching how fast he would go down this steep thing. But yeah, so for me, it was just unbelievable to hear when I heard about the brain cancer that he had this. And I have here some email. I was corresponding with him about something else. And when I found out about this, I told, so just to quote this email that I wrote to him, I have enormous respect for you and look up to you as a hero, scientist, strong bicyclist and athlete, wonderful human being and a mensch. Mensch is like someone who does the right thing. He was always very kind of responsible. And yeah, so it just feels kind of like such an incredible shock and loss that he's not here anymore.
Thanks, Ken. Okay, now I invite Fernando, who overlapped with him at Texas.
Okay. Well, thank you, Atish, for organizing this, and Narayan, who I don't see, also for suggesting it at some point. And I think it's difficult for me to accept that we're talking about Joe. He was such an impressive and close person to many of us, and I'll try to control myself. Sorry. I got to know Joe since very early, when I was a student. So it was in the early 80s, and he came. It was his actually his job interview when we were students in Austin. He came, I think, in 83, 84, and so this was a figure that I already knew, and I already knew for the paper that both Igor and Ken mentioned. Is this the Polchinski-Soskin paper? Because at that time I was just assigned. My first project as a student was precisely to take the Polchinski-Soskin model and couple to supergravity. That was my exam for the thesis, and that's that Weinberg suggested to another Joe Licken, to support me, and then Joe Licken proposed that, and we worked together precisely on that paper. But then Joe came for the interview, and the interview was precisely on this paper of the effective Lagrangians in the randomization group. At that time, I was surprised because I knew his supergravity and supersymmetry papers, and then he came out with a very deep idea, and which was not fashionable. Nobody else was working on that at that point. And it was extremely impressive, the way he gave the talk. And there was immediately, of course, Weinberg gave him the offer, and he joined the group in 84. And since then, he was incredible. So we had all these experiences with him since every day we had this lunch seminars with in the Weinberg's office, and he essentially became Weinberg asking a question, and we all looking at Joe for an answer. And he came out, of course, with a great answer. Very few words, but very deep thinking, and that repeated over and over several years. And also for my thesis, because we all started working in string theory at that time. It was in 84, 85, everything moved because of the Green-Schwarz papers. And so we started teaching each other about different aspects of string theory, and he included the students also in the presentations. I had to give a presentation about the spectrum of the theories, and then he particularly took the Polyakov string as his subject, and so he gave several lectures about the Polyakov string, and then on top of that, Polyakov formulation of string theory, and it was the covariant way, and then that drove him to write this famous paper on the one-loop path integral for the bosonic string that became very, very influential over the years. And then, so he encouraged us very much, in particular for me in my thesis. And so we wrote this paper on string effective actions that he liked it very much, and he was very, very supportive for us. And then I had my thesis exam, my PhD exam, and he was one of my examiners. Actually, I realized at that moment that it was the first time he was examining a PhD student. It was his first PhD exam, as an examiner, of course. And of course, we all get very nervous when we give the presentations. I gave my presentation, and usually it's very straightforward, because once you get to the thesis, you give you know already that you have passed, because you have papers and you have been approved to give the presentation, but still we were nervous. And so usually you give the presentation, and then people ask simple questions, and everybody then after some point leaves. And but this time, since it was Joe's first thesis examiner, he came with a long list of questions, 2 pages full of questions. So I finished my talk, everybody asked simple questions, and then everybody left, and only the examiners remained. And then Weinberg, who was the chairman, he said, okay, now we have to proceed. And then Joe said, yes, I have all these questions. I think I saw the big list, and then so he started to say, well, and then when he was starting to talk, Weinberg said, come on, Joe, you can do it later, so let's finish this. So ask him in person. So that was the end of my exam. So I was so relieved with Weinberg. So that's why I managed to pass. And after that, after I left Austin, I have to say that he also helped me a lot, first of all, with recommendation letters to apply for postdocs positions. But not only that, he also suggested who should I work with. For instance, when I went to CERN for my first postdoc, he said, well, these are the groups, you should try to go with this group and work with these people, because I think they're doing interesting things. So that he went beyond just writing letters and giving you advice. And over the years, he was the same. I met him every year or two in different conferences or so. He was always very, very encouraging and supportive. And we have plenty of discussions about physics, and that I always learn something from him. You know, I think you can have many conversations with many people. When anytime I talk to Joe, I recorded that in my memory, and I don't forget it. So at some point, I did some research in different directions that we didn't interact too closely, but we always met in conferences and talked to each other. And then in the early 90s, he sent me 2 chapters of his book that he was writing for review, and something that had to do with what I was working on. So he asked me for my opinion. So of course I took it very seriously. It was like 30 or 40 pages. So I went through the chapters and sent my comments and so on. Unfortunately, that was all that changed after the Dbrane paper came, and most of the material in those 2 chapters didn't appear in the book, because essentially he changed the whole book while he was writing it. So, but it was nice for me to see that. I mean, he sent me these papers to read, and of course, when they all say that the Dbrane's paper made a big change in the community, and so we all try to learn Dbranes for different reasons, for more formal aspects, also for more say phenomenological aspects. And in my case, I use that to start moving towards more phenomenological aspects of string theory. And then, of course, by having Dbranes, you change the picture of the brainboard scenario, and then you can have now the type 2 string theory, type 2A and type 2B, that were considered to be, there was a no-go theory about getting something realistic for them. Then Dbranes changed the whole picture, and you can have now the whole standard model within Dbrane, and then it created a lot of activity in that field. Also, after the work of Valia and Taya, we got also interested to take in, they were doing Dbranes to create inflation. We took a picture of a brain and anti-brain to be attract each other, and that will be the proposal to get inflation. And at some point, when we proposed that, of course, following the brain pictures of Joe, and when they will get too close, there will be a tachyon that will appear, and the tachyon will end inflation and create some topological effects, including cosmic strings and so on. And Henry Tide took that idea further towards the cosmic strings, but then Joe came to the picture, and he just saw, oh, these are very interesting things coming from the picture of brain inflation, and the cosmic strings can have observational implications. So he wrote this beautiful paper with Ed Copeland and Rob Myers, and but not only that, he took very seriously the idea that they could be eventually being detected. And so we went to several conferences together, and at some point there was a group here in Italy claiming that they have seen something that would look by gravitational lensing like 2 galaxies looking identical, so that would be perfect to fit with the idea of that there was a cosmic string, a stringy cosmic string there. And it was Joe who went, everybody went to confront all the observational people to make sure that he understood what they were measuring, and to make sure if he believed or not the results. At the end of the conference, it was just one direction between him and the experimentalists, and then at the end he convinced himself that it was not a real evidence, and he was right, of course. And then in 2001, when his paper came with the Dbrane Polchinski, I asked my postdoc at that time, please stop doing whatever you're doing and just work on this Flaps story, because that's the most promising approach. And then from then on, we have been following that famous paper, GKP, of model stabilization. And then we met several times in the Santa Barbara meetings in 2003, 2006. Then, when I became the director in 2009 here, we organized a special activity and to the 45th anniversary of ICTP, plus the 25th anniversary of the Dirac Medal. He had won the Dirac Medal the year before. So he came, he was very, very, very active in the activity. And on top, one of the things that I remember very well is that we had a special dinner, and he was the after-dinner speaker. And so he gave a very funny presentation as usual, but also very touching for me. I think it was very supportive in general for ICTP and for myself, which I always thank him. And then we touched again in 2015 for two things. One is that he wrote this paper about people were criticizing the anti-brain that do the uplifting, this KKLT scenario. And he came out with a paper supporting it, and was very strong supporting it. And then he gave a talk at the SUSI conference in 2015 regarding that. At that time, I had written a paper in a similar direction, so we discussed about how to make the presentations. And he gave his presentation, which was not only very well received, but he even wrote a paper to make clear that he made the point clear to everybody. And at the end of that year, that's when became the sad story. We were supposed to meet at that conference in Munich. There was a discussion about the string theory, how probably you have all heard about this conference, which is why trust the theory. And he was going to be the main person in the conference. And just a few days in another conference in Berlin, he had this episode that was at the end gave to the discovery that he had this tumor, and he couldn't make it to the conference. And then, to finish, last year, we had, after 2016, he was supposed to, they're organizing a small event for me for my 60th birthday, and Joe was supposed to come. I was very generous from his side again, and he canceled because of his health problems, but he sent a long document about it, and he asked Shanta de Albas to read it for me. It was also very, very emotional from my side, and we have recorded that part. We have recorded. But then last year something happened that we were working again with Shanta de Albas and my student here, Veronica Pasquarelli, on some ideas about backend transitions and so on. And we came across one of his papers in the 1990s. So we just sent him an email. So Joe, we knew that Joe was ill, but he was, we have heard that he was still active and so on. And he replied immediately to our question. We asked him some concrete questions about his paper, where he was criticizing the Hartle-Hawking wave function and so on. And he replied extremely enthusiastic, and within a period of, say, 6 weeks or so, I received like 20 messages or 25 messages from him, going back and forth about all these ideas about how to understand these backend transitions and so on. That essentially, it took essentially most of my time, because following Joe is not an easy task. I think that whenever he sends something, you have to think twice about it, and or many times about it. And we had to discuss internally with Shanta and see what he meant or so. And but also we exchanged several messages about other things, about people criticizing some aspects about the string theory or so. So let me read something that he sent me on the 7th of August last year. So he said, by the way, I have a new principle. If we have a seemingly powerful no-go theorem, then we will find a powerful exception just beyond the limit of validity of the theorem. Example, no stable atoms in classical electrodynamics, no symmetries beyond Coleman Mandula, no composite graviton in field theory, no de Sitter in classical GR, including branes. And there are others. So I don't read the rest of the message because it's more personal, but essentially that was, I would call that Joe's principle, which I sympathize very much. So that's very, very good. And sadly, after a few days, 3 weeks after that, when he posted his memoirs, then he sent an email that he was going to be needed special treatment, and then we stopped the exchange after, I think, in mid-September. We stopped receiving emails from him, and then I didn't know more about him until January when Dorothy sent this email saying that he had another episode, that he needed some, that he was already in the hospice, and she asked for people to send messages, encouraging messages to him that many of us sent, and I think that's what Igor got this message from Weinberg precisely in that statement. And I have to say, Joe has been such an impressive person. I really had a deep admiration for him, and as a human being, as a physicist, his generosity, his kindness, as Dorothy said in her message, and he will always be remembered. One thing that by reading it, you have read the Matt Strassler's article about Joe. He at some point said that because they had this D0 understanding of the vertices of baryons, they say, well, there will be a D0 in every proton and neutron that we see. Probably it's too much to say, but I would say probably our world can be actually a Dbrane. In that sense, imagine who else could have thought that one object that you invent can be the whole universe, which is maybe a Dbrane. But I'm sure Joe's legacy will remain for many, 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 many years, not forever. But for all of us who got to know him, as a human being, we have the great privilege to have been exposed to this exceptional human being, and we are very thankful to him for all the things that he had done for us. But thank you.
Okay, thank you. If somebody else would like to add something. So, I guess it's not easy to get back to work after this. Maybe we should take a 5-minute break and then reconvene. And let's once again keep Joe in our memories, and we will continue with string theory in 5 minutes from now.